All right, boys and girls, in the last one, we learned how to solve an exponential equation by using a logarithm. So today we're going to do the other way. We're going to go start with a logarithmic equation. We're going to use exponents to solve it. Our prior knowledge is a little bit more extensive today. The first one is just the relationship between exponential form and logarithmic form. We should have that memorized close by now. Next three are all the properties of logarithms. We're adding two logarithms. You multiply their parts. For subtracting, you divide their parts, and if we have a part raised to an exponent, that exponent can be multiplied as like a coefficient in front of the logarithm. So our first example today, solve the equation log of 4x minus 3 is equal to 2. Now the base isn't shown, which means it's 10. So what we actually have is base 10 here, and converting from this form over to this form. Okay, again, we set the base with 10. This part right here is going to be the x, and this would be the y. So what we actually have is 10 to the second power is equal to 4x minus 3. Well, that's easy enough to do. 10 to the second power is 100, equal to 4x minus 3. Now it's just a linear equation. Pretty straightforward. What we do from there, you just add the 3 over. You're left with 103 is equal to 4x. Dividing by 4, x is equal to 25.75. All right. When we have some properties involved with our logarithms, it gets a little bit more complicated, but it's nothing too bad. The very first thing that we want to keep in mind is the logarithm by itself. Okay. Right now we have the 2 in front and the minus 3 at the end. Now, if these were in parentheses, the minus 3 would be part of the part of the logarithm, but it's not. So we can go ahead and get rid of this minus 3 by adding 3 to the other side. We're left with 2 times the log of x is equal to. Now, you might be tempted to just divide both sides by 2, but remember, a number in front of a logarithm becomes the exponent of the part. So what we actually have here is the log of x squared is equal to 2. Okay, so then when we convert it into exponential form, again, the base is 10, it's not shown, so it's 10. You have 10 squared is equal to x squared. Okay, so we have 100 is equal to x squared. And the reason why we had to add this squared is because when we put the square root in an equation, we get plus or minus. So we have plus or minus 10 as the solutions to this logarithmic equation. Now, you do need to be careful though, because when we check, and we haven't done this before, but when we check in a logarithm, you are not allowed to take the log of a negative number. It doesn't work. Okay, if we try to do the log of negative 10, you get a non-real answer. You get a domain error. Okay, so this negative 10 is actually an extraneous solution. So negative 10 is extraneous, meaning that x equals 10 is the only one that does work. Okay, so just be careful with that. On this last one here, if we have two different logarithms, we have to remember how to combine them into one. If we are adding, we multiply their two parts together. So we have the log of x minus 3 times x is equal to 1. Well, we'd have to distribute this together. So this becomes the log of x squared minus 3x is equal to 1. Okay, so the logarithm is by itself, base is 10, so we have to convert to exponential form. So we have 10 to the first power is equal to the x squared minus 3x. Well, 10 to the first power is just 10. So we are left with this right here, which is a quadratic equation. So those haven't gone away. We need to get set equal to 0. So we're going to subtract 10 over to the other side. X squared minus 3x minus 10 is equal to 0. You could use the quadratic formula if you want to, or remember how to factor the factors of negative 10 that add up to negative 3, negative 5, and positive 2. That still equals to 0, so we set each one equal to 0. You get positive 5 and negative 2. But again, look up here at the original problem. If you put in the negative 2 into this one right here, or this one, it doesn't really matter. You're taking the log of a negative number. That means that negative 2 is an extraneous solution, and the 5 is the only one that works.